Hi, this is a lesson that doesn't really relate directly to what we've been learning the last couple of classes, but it's about sequences and series, which are a pair of tools that you're going to need for the remainder of this unit. So here we go. Let's start by talking about sequences. Okay. A sequence is a series of numbers that is determined by some sort of rule. For instance, a sub n equals 4 times n minus 1 would be an example of one of these rules, where n is the number of the term. So the problem asks us to list the first 3 terms in the sequence. We would call those terms a1, a2, and of course a3. And to determine the value of those terms, we would input 1, 2, and 3 in for n on the right side of this statement. So we would get 4 times 1 minus 1, which is 0. 4 times 2 minus 1, which is 4. And 4 times 3 minus 1, which is equal to 8. So when you're asked to find the terms of a sequence, it just means plug 1, 2, 3, and so on in. What we're really more interested in here is the other way around. This time, number 2, I have given you a sequence of numbers that have a pattern. And I'm asking you, what's the next term in the sequence? And then what's the 100th term in the sequence? So you begin by seeing if you can find a pattern. And in the case of this one, the pattern that we should notice is that to go from 4 to 9, from 9 to 14, 14 to 19, and 19 to 24, each time we are increasing by 5. Therefore, the next term in the sequence will also be increased by 5, which means that we will have a 29. Now we need to find the 100th term. And we don't want to have to add 5, add 5, add 5, add 5, add 5. So what we're going to do is write what's called an explicit rule. Here's how you do it. I'm actually going to take the paper. I'm going to turn it this way. You should do the same. And I'm going to list the terms. This is term 1, 2, 3, 4, and 5. And then I'm going to take this 9, and I'm going to rewrite it. Because what 9 really comes from is taking the 4 right here and adding the 5 to it. So this is 4 plus 5. And then let's go to the 14. The 14 is really the result of come all the way back here, taking the 4 and adding 5 and then 5. So here we're taking 4 and we're adding to it 2 times 5. And then let's go to the 19. You see the pattern now. 19 is the result of come back here, 4 plus 5 plus 5 plus 5. So this is 4 plus 3 5s. And you can kind of imagine that the next one is going to be 4 plus 4 5s. And just so we can see the 4, 3, 2, I'm going to take this 4 plus 5 and rewrite that as 4 plus 1 times 5. Now, mark those 4 numbers and notice how they relate to the term numbers over here. Namely, that the number that is coming up in the sequence is always 1 less than the term number. What that tells us is that when we get to, say, the nth term, what we're going to have over here is 4 plus a number times 5. And that number that goes right here will be 1 smaller than this value. So we'll call this n minus 1. So what I have right here is called an explicit rule. It's explicit because if I tell you the term number, you can tell what the term value is. And now we can pretty quickly figure out that for the 100th term in the sequence, A100 will be equal to 4 times 1 smaller than 100 times 5, which is going to give us 499. I'll write that here. Next one. Same game, this time the pattern is different. Half, 3 halves, 9 halves, 27 halves, 81 halves. Each one of these is being multiplied. The thing it's being multiplied by is 3. Therefore, the next term. Hi, Stella. You want to say hello to my students? No? All right. Is going to be 81 over 2 times 3, which is going to give us 243 over 2, right?
Yeah.
So now I want you to write an explicit rule. So let's turn the paper this way. Can you shut the door, dear?
Sure.
And let's number these terms 1, 2, 3, 4, 5. And let's play the same game we did over here, except for I'm going to write this one as a half multiplied by 3. And then the next one is a half multiplied by 3 and then multiplied by 3 again. So that's a half times 3 squared. You ever heard of a square?
No.
And then the next one is going to be a half multiplied by 3 by 3 by 3. So it's 3 to the third. And not too hard to figure out that the next one is a half times 3 to the fourth. Now again, throw one right there. We see this pattern of numbers in our exponents, and we look at how those are related to our term numbers, and we can see that these are always one fewer than these. Therefore, your explicit rule is going to let you really want to put your hand under there, don't you? Go ahead, do it. Wave at everybody.
You keep working.
I'll do that. AN is 1/2 times 3 to the n minus 1. One more of those. Let's come down here. Now, I always pick these examples for a reason, and I picked this one out because it's identical to the last one, except for we have this alternating pattern where every other one of the terms is negative. And usually when that happens, it means you are multiplying by a negative number. In this case, it's times -3 times -3 times -3 and times -3, which means that our rule is going to be a half times -3 to the n minus 1 power. Okay, let's turn the page over. I'm teaching a lesson because I'm not going to be at school on Monday.
Okie dokie.
All right, here's what I want you to do, folks. I want you to try finding a pattern for 5, 6, 7, and 8. And then once you've tried all of them, I want you to go to the second video and check your work.